we're going to talk about testing the difference between two population means. So we'll have two samples from two populations, and we want to know, is there a difference between the means? Now, the null hypothesis we'll be working with is that the difference between the means is some value d naught. A common value to choose for d naught is 0. When we do that, the hypothesis we're looking at for our null hypothesis is that there is no difference between the populations. Our alternative hypothesis that we're going to look at today is that the difference between the means is not equal to d naught. Now, this is considered a two-tailed test. We're going to talk about one-tailed tests where we're simply interested in whether it's less than that value or greater than that value at a future time. But today we'll talk about the two-tailed test. So when we have two populations, and two population means two samples that we're working with, we have four options. Now we've seen all four of these options before when we were working with confidence intervals. So hopefully what follows is pretty much review for you at this point. So the first option is that our variance for our first population and our variance for our second population are both known. In this case, we can use z and use the normal distribution. So we calculate a z value using the formula given there. And we're going to reject our null hypothesis if our z value is less than our negative z sub alpha divided by 2, or if it's greater than our z sub alpha divided by 2. So again, this should feel a lot like confidence interval work, where if we have a value outside of our confidence interval for our z, our computed z, then we are going to choose to reject. Option 2 is that we don't know the two variances, but we know that they're equal. So we'll have two population variances that are equal to one another. Now this might happen if we take the two samples from the same population, or if we're given some other reason to believe that the two population means would in fact be the same. So if this is the case, then we can use the t-statistic and the t-distribution. So notice in this one, we're using the sample, the pooled sample standard deviation in calculating our t-value. So our pooled value for our variance is given there. There's nothing different about this than what it was when we were looking at confidence intervals. So again, the pooled sample option is no different than the confidence interval situation where we pooled the samples. And we're going to follow the same rule where if t is greater than t sub alpha divided by 2, with n1 plus n2 minus 2 degrees of freedom, or if t is less than negative t sub alpha divided by 2 with n1 plus n2 minus 2 degrees of freedom, we'll reject our null hypothesis. Otherwise, we're going to fail to reject it. A third option is that we don't know either of the population variances and we believe that they're unequal. If this is the case, then we again use a t-statistic and the t-distribution, except for we don't use the pooled variance. Instead, we use each sample variance. And again, this formula should look similar to what you saw, in fact, exactly the same as what you saw when we were dealing with confidence intervals. Now remember, this is where we have our degrees of freedom, v. We have a little bit more of a formula to do, and you'll want to take the floor of that formula. You'll want to round down for the number of degrees of freedom. And again, we're going to reject if our t-value is too extreme or outside of what that confidence interval area would be. Our final possibility is that we're in a situation where we should be pairing things. So we worked with the example of a taxi cab tires being paired, pre-test, post-test with the same student, any situation where we are pairing. Now, in this one, our null hypothesis is that our mean difference is going to be D naught, and our alternative hypothesis is going to be that our mean difference is not equal to D naught. So again, our t-statistic that we'll use should look basically exactly like what we were dealing with the confidence intervals, and we're going to reject if our t-value that we compute, our t-statistic, is too extreme. So again, as you're going through this, I can't stress enough to be connecting this to the confidence interval stuff that we've already done, and also to the single sample stuff. If you put those two things together, then nothing in this lesson should feel new to you.